Okay, now we are going on to the questions that we have done in exercise 19.1. Okay, now as I've said, do not be too worried if you do not know how to do them, but you make sure you understand the questions, the answers that I'm going to explain. Okay, let's look at question number 2. You're supposed to prove that DE is parallel to BC, and part 2, given that BC is 2x, explain why DE is x cm. Okay, now the question already say that D and E are midpoints. So we have AD equals to DB and AE equals to EC. Okay, so this will imply that DE is parallel to BC because these two are midpoints. By the midpoint theorem, they'll be parallel. So by midpoint theorem, DE is half of BC, and since BC is 2x, we substitute in, we'll get x cm. Okay, this is how we explain why. Alright, let's look at question number 4 now. In the diagram, MN and BC are parallel lines, and angle NMC is equals to angle NCM. Prove that triangle ABC is similar to triangle AMN, and this product is equals to that product. Now when you see the product, most likely we are going to use similar triangles. Okay, now I'm going to start here. Now angle MAN is equals to angle BAC, okay, because they are common angle. Angle AMN is equals to angle ABC because they are corresponding angles, parallel lines. So therefore, triangle ABC is similar to triangle AMN because of AA similarity. Now, because of this particular similarity property, AC over AN is equals to BC over MN. Okay, now we can cross multiply, we get this answer. Now we must also note that MN is equals to NC. MN is equals to NC because this is an isosceles triangle. Because we are given that these two angles are equal, therefore these two angles, these two sides must be the same. So we have AC times NC, we replace MN with NC, and BC times AN. So when we rewrite according to the one that we want, we have already proven the statement that they want us to prove. Okay, so that's your question number 4. Next, question number 6. Alright, for question number 6, we are supposed to prove that AQ is equals to EP, triangle ABQ is congruent to triangle EDP, and angle QBA is equals to angle PDE. Now, first of all, we know that AQ is AP plus PQ. Okay? EP is EQ plus QP. Now, the question says PQ is equals to QP. PQ is equals to QP, of course, because it's the same length, and AP equals to EQ, given by the question. So AQ is also equals to EQ plus QP. So since they are the same, okay, EP will be equals to AQ. Alright, so I repeat, AQ is AP plus PQ. So we replace AP, I repeat, AQ is AP plus PQ, and EP is EQ plus QP. Okay, so since PQ is equals to QP and AP is equals to EQ, alright, we will replace AP replaced by EQ, PQ replaced by QP, so EQ QP is EP. So these two will be the same, proved. Alright, now for part 2, AQ is EP, we have proven in part 1. Angle BAQ is equals to angle DEP is given. These two are base angles isosceles triangle. Okay, so these two triangles will be congruent because of AAS, angle, side. Okay, angle, side. So let's take a look here. AQ is here. This is the length. Angle BAQ, this is the angle. And angle CPQ, CQP, my goodness, CQP, that is this angle. Okay, So we have AQ the same, AQ, angle BAQ, angle BAQ here, and angle CQP, CQP here. So angle, side. So it's the AAS property. Now, since we know from part 2 that angle ABQ is congruent to triangle, I'll wrote 2 times, so this is wrong. Triangle ABQ is congruent to triangle EDP, therefore angle QBA must be equal to angle PDE. Okay, this is from the congruent statement. Okay, now we move on to question 8. Question 8, we are supposed to prove that triangle ANT is congruent to triangle ELR. Okay, now, first we know that AG is equals to EG given. Triangle AGE is therefore an isosceles triangle. So therefore angle GAE is equals to angle GEA because of base angles isosceles triangle. Now we know that AN is given by AG minus NG, and EL is EG minus LG. So it's given also that AG is EG and NG is LG. We'll conclude that AN is EL. Okay. Now take note also that AT is actually AR minus TR, and ER is actually ET minus TR. Now since AR is equals to ET, alright, AR is equals to ET, so we will have AT equals to ER. Okay, because these two are equal, these are also the same, so AT will be equals to ER. Now this is to prove the second part. We have already proven AT is equals to ER. So we are supposed to prove that triangle ANT is congruent to triangle ELR. So AN is EL, proven. Okay, AN is EL. Angle NAT is equals to angle LER. Alright, AT is equals to ER. So triangle ANT will be congruent to triangle ELR because of SAS, side angle side property. Okay, now you can see that in this particular question we have to prove a lot of things before we can use the SAS property. So this is the difficult part in geometrical proving, because sometimes we do not know the direction. Okay, alright, now next we move on to question 11. Okay, let's move on to question 11. Now, we're supposed to prove that D is the midpoint of AC and AEC is an isosceles triangle. Now, we will prove that triangle ABC is similar to triangle EDEC by AA similarity. Okay, now you can see from this statement and this statement is the AA property. So because of this this similarity statement, I can write these two. Okay, and I know that DC over AC is half because I know that D is the midpoint of AC and also E is the midpoint of BC. Okay, so D is the midpoint of AC. Now, next, I'm going to show that ADE is 180 minus 90 because this is adjacent angles on straight line 90. AD is equals to CD because D is the midpoint, and DE is a common side. Therefore, triangle ADE is congruent to triangle CDE by SAS property, and AE will be equals to CE. Now, if AE is equals to CE, it will prove that triangle AEC is isosceles because I have two sides equal. Okay, so this will conclude your question 11 of exercise 19.1. Alright, thank you class.